Now, are you ready for division? Now, division is troublesome for completely different reasons. Division is troublesome for whole numbers for one reason. Division is troublesome for fractions for completely different reasons. And unfortunately, they're never addressed in your textbooks or by your college teachers. All right, I want to do a I want to do clicker. Are you ready, Winnie? Okay. I consider 27 divided by 8. One, this is a division. And the notation is correct. Two, this is not a division, period. Three, what's the right way to say that? Yeah. Oh, but you cannot click on one and one. So.
You can do all of the above, or both.
Oh, you can do both.
You go. You make that your choice is both answers.
Oh, okay. No, not both, but
There's another way.
Like A, B, or just give all of the above, none of the above.
yeah, none of the above. Okay. Oh, yeah. Before you click, let cancel your clicks. Sorry, because my question is not clear enough. All right. So we are all right now. All right. Now, of course, you know a lot of things, but as far as we're concerned, we're starting from the beginning. So up to this point, what do we know? Just whole numbers, right? So I want this understood. Among whole numbers. Okay, all right, now you can click again, that's fine. Are we done? Are we?
I have these combined to but I can go ahead and close it. Oh, there it is. Thank you. There we go. Okay.
This is, no, hey, pretty good.
What's the percentage?
Yeah, middle is 63% says not a division.
63%.
Yeah.
How many says it is a division?
16 is a division. 21 says not, neither. Now that's great. Would someone be willing to explain to me why he or she does not consider this to be a division? I just want some reason. That's what a clicker cannot do. And so, if you don't mind, can I get some detailed explanation? Okay, Kelly.
I think it's because within whole numbers, division is only defined if, how to say it precisely, if the smaller number is a multiple of the bigger number.
And the result.
Okay.
The result is a whole number.
Okay, good. Yes,
It
Deborah?
won't fit into equal groups.
Very good, okay, yeah, okay. It's a different way of putting it. Someone else wants to volunteer an opinion? Just random, that's all? That's all you, both people have expressed what you want to say? You never heard of 3 remainder 3? Never heard of that? So, okay, I mean, so what is wrong with say this is quotient 3, remainder 3? It's correct, no? 3 times 8 is 24, the remainder 3. What's wrong with that?
It's not quantifiable.
Oh, it's I don't know what that means, but it's quantifiable. It's perfectly. Well, you're going to do that. Are you going to get a quotient and a remainder at some point? What do you think you're doing then? If this is not division, what do you think you're doing? What do you think you're doing? What?
It's a big.
Okay, but at least the fact that you have some doubts, and that's a good beginning. And you see, this is the main difficulty of the concept of division in whole numbers. Now, among fractions, then there's a different issue. The whole number problem is the problem of division with division among whole numbers is that the word division is thrown around carelessly. What is a division to you? Now I cannot do clicker on this one. So what is division to you? Can someone just give me an idea? What's division? General concept. We have addition, right?
Right.
We have subtraction, right? We have then multiplication. Now we do division. What's wrong with that? Yes?
So in my classroom, that would be the 27 pieces of candy thrown on the table divided equally among 8 students. And how many extras are there going to be? So I would call that division.
Okay.
And
Okay. See, that's what I'm saying. But so did you click 2 or 1 then? If you that's division.
I clicked 1 because
Right.
in my class
Okay.
that would be
Good.
division.
Good. Okay. Now other people, just be more forthright and just say something.
Partitioning a whole unit into pieces of equal size.
Okay. In this case, what do you get then?
Remainder, like in this case.
Okay. Right. So do you say it was division?
I said none of the above because the symbol.
It's what?
I said none of the above because the symbol's not correct.
Okay. What would you consider to be correct symbol?
And I guess I just had pre-read, so that's what.
You had what?
I had pre-read the little.
Oh, I see. No, it counts. It counts because anyone who makes that extra effort, right? It's fully deserving of full grade. I mean, no, absolutely. I mean, you have read it, then you read the preface of the chapter, then you understand what the issue is.
You use the division bar in this
Yes.
case.
That is the problem among whole numbers. Division is thrown around to encompass 2 things. One is the operation of division. The other is a separate operation, really has nothing to do with division, except, well, I'll give you a little footnote on that one. It's division with remainder. One concept. All right? Division with remainder is not division in the same way a seahorse is not a horse. That makes sense? Or a butterfly is not a fly. Right? You have to understand that. Right? So there are two distinct concepts. One is division. The other is division with remainder. And I'm sorry to say that even I did not emphasize this fact at the beginning, and somehow thought that I've explained enough and teacher would get the idea, but it turns out it's not true. That if there's such a fundamental misunderstanding, then I should have made it more clear. And that's exactly what finally came out in the book itself. The earlier draft did not emphasize this point. Okay, so now let's back to square one. We say this is not a division. So what is a division to you? As I said, we have talked about addition, subtraction, multiplication, division. You must agree they're on equal footing, right? They're on equal footing. So what is in common among all these four operations in principle? Addition, subtraction, multiplication?
Their way of counting.
Can you be a little bit more specific?
The answer is
No. Sorry?
the answer is a whole number.
Good. Can you be a little more specific?
What?
Can you be a little bit more specific?
Are we still talking only whole numbers here?
I think that's all we know.
Oh, okay. Just want to make sure.
You see, yeah, okay. Yeah.
Repeated subtraction. It's division.
I cannot say yes, I cannot say no. Right? Okay, let's leave it in that limbo status, okay? What I want to get out of you is that when you talk about an operation, which is arithmetic, numbers and operation, remember? Numbers and operation, that's the standard terminology, no? When you talk about that, the operation you're referring to is actually very specific. In mathematics, it's very precise. What it does is what? I give you only two whole numbers. You have to come up with a third whole number. That's what we mean by an arithmetic operation. Try it. Give you two numbers. You add, what do you get? Whole number. Give you two whole numbers. Well, provided one's bigger than the other anyway. You subtract, what do you get? Whole number. Give you two whole numbers. We just finished multiplying them. What do you get? The whole number. So I give you two whole numbers and I say divide. You're supposed to come up with a whole number. And this fact is always fudged. And this is why your students have so much trouble with division. And of course, what I've just said makes no sense to you maybe at this point, right? But we're going to go through it carefully. So with the document camera there, I show you one nice example of can we turn off the light maybe? Or maybe, yeah. I think, may I zoom in a little bit? And, this is thanks to Cynthia. I should have warmed it up earlier.
Yeah. Good.
Oh yeah, slowly coming in. Yeah, so what I want to show you is a page from a textbook. Now every time I show you one of these samples, please do not believe that I'm singling out and I have to search high and low to get this piece of anomalous writing for you. On the contrary. All textbooks basically are the same, no matter what they say. You go inside, they say exactly the same thing in the same muddled manner.
What grade is this?
This is I think it's either second or third. Let's see.
Can you zoom in?
I'm trying.
Soon, yeah.
I think it's very much like
That's
four.
Oh, I will zoom in. Zoom in. No, zoom in.
Fine.
You're good.
Okay.
Could be third.
Addition and subtraction. I think either third, probably third. It's about linking addition and subtraction. They're called inverse operations. Now, you see the word abused right there. What do you mean by inverse operations? Tell me.
Multiplication and division are inverse operations. Addition and subtraction are inverse operations.
Yeah, what does it mean?
Well, you have to explain it all.
What is undo?
What's an operation? What did we say an operation was?
Getting a third number.
I give you only two numbers.
Get a third number.
All right, so now you tell me how they inverse each other, right?
Using that
I
third
give you
number from
5.
the first two.
I give you 2. You add, you get 7, right? You subtract, what do you get? 3. So in what way there's inverse?
Yeah, because you have to start with the 7 on the second.
No, wait. You don't change the rules.
Well, they do.
Unfortunately, this is not a democratic process. Right? Just because everybody tells you to, doesn't mean you should follow. You said an operation is what? Repeat, right? I hope you all understand the point I'm trying to make. We agree. You agree on one meaning of operation, then stick to it. We said operation is what? Given 2 whole numbers, you give me a second one. Okay, I give you 5 and 2. I said add, you give me 7. 100% correct. I said subtract, and you give me 3. That's also correct. Now explain to me in what way these are inverse operations. No, it's not interesting. It's just routine, Sandy. Very routine. You have to be literal in doing mathematics. In other words, if you at any given moment, you tell your students, well, no, look, I really didn't mean that. You understand. You can interpret it differently, and then you get it. You see? I don't know whether you say it or not, but in effect, textbooks say this every day. I ask you, as a learner, what are you going to do? First of all, is there any incentive for you to learn anything under the circumstance? Because whatever you learn, at some point, someone more clever than you is going to come in and say, well, look, I didn't tell you this, but you understand. You can just interpret it differently. See? Now you understand. There was a purpose of learning all the things that went on before. Whatever I learned is not going to be enough. So what should I learn? You have to be attuned to this basic psychology of learning. This is why we have to be literal, meaning that if I say this is what it is, you can't change it in the future and say, well, just fudge it and you get it. That's very bad for learning. Right? So that's why I'm trying to impress on you. This is not making any sense. Right off the bat, this is just talking nonsense. And of course, as you all know, this is common language, right? Multiplication and division are inverse operations. And in fact,
On the side, the white button. On the very top.
There you go. There you go. Just let go.
it's not good, is it?
You have to press it once and let
It's
go.
okay, it's okay.
Press it once and let go. There you go. Yeah.
Maybe I can zoom in one more time. Can you read better?
No.
Well, I mean, there's nothing more to it than just that line. It says addition and subtraction are called inverse operations. So the way they explain it is the following. 3 plus 9 means 3 is added to 9 is added to 3. Think about that for a second. Subtraction can undo addition. 3 plus 9 minus 9 equal to 3. 10 minus 2 means 2 is subtracted from 10. Addition can undo subtraction. 10 minus 2 plus 2 is equal to 10. Now they are introducing a new concept of operation. What it is what? When you say an operation, you mean you hold one number fixed and only consider changing the other number. Therefore, when you say 3 and 9, you somehow you learn that the right thing to do is don't listen to what I ever said, hold the 3 fixed, and add the 9. And then you want to subtract, you ignore the 3, you just say, well, you just fix the 3, then 3 plus 9, subtract the 9 now, then you get back the 3. That's a completely different concept of operation. You get it? No. 9 and 3, right? You want to add is 12. Want to subtract is 6. But the author says, no, I didn't mean that. What I mean is, when I tell you to do something, you hold this fixed. You hold this fixed. Don't do anything. Don't do it. So when I say add, okay, you just add the 3. When I say subtract, then what you do is, from here, subtract the 3. Oh no, I mean subtract the 3, then you get 9. And I say, I started with 9, and then now I can go back to 9. Well, I just introduced you to this idea, and we can talk about it more if you want to. But this is in connection with why the concept of division is so completely muddled in school mathematics, because you do not have a firm concept of operation, which, let me repeat, given 2 whole numbers, you're supposed to come up with a whole number. If you don't keep that fixed, then you're going to have a lot of trouble understanding what division is and what division with remainder is. And yet they're related in some ways, but you also understand it's not the relationship that's important, but the fact that they're distinct operations. All right?